Hey everyone, welcome back to the channel. And if you are someone who wants to crack coding interviews at top companies, whether that's Google, Amazon, and any product-based company, you are in exactly right place. Because today I'm giving you the complete DSA roadmap for 2026. It's step by step from absolute zero to interview ready. And the best part, this roadmap work whether you are a total beginner or like college student or someone switching careers. And I have broken everything down into 7 phases, each one building on the last, so you always know exactly what to study and what to do next, right? So if you are serious about cracking coding interviews in 2026, smash that like button, subscribe, and let's get into it. So the first and the very important thing, like before we start, let me answer the question I get asked all the time. Is DSA still relevant in 2026? Right. So most of the people generally ask, even like in Twitter, LinkedIn, and in many other places, like with AI tools everywhere, do we still need to learn data structure and algorithms? The answer is yes, and here is why. Every single top tech companies, Google, Amazon, Meta, still conduct DSA based coding rounds. This has not changed. In fact, with more people applying for fewer spots, the bar is higher than ever. So, this is not just about cracking interviews, it trains your brain to think logically, to break down complex problems, and to write efficient code. So, that skill, no AI can replace it. So here is the roadmap, 7 phase. Let's walk through each one, right? So I have created this beautiful roadmap. So if you want, you can let me in the comment section. I will also share it in the comment as well. So let's start the first phase. So what's the first phases look like, and how much time you have to spend? So 2 to 4 weeks is enough to actually cover all of them. So first phase is your foundation, and I cannot stress this enough. If your foundation is weak, everything on top will collapse, right? So make sure to understand it, right? So the first, pick your language. For competitive programming and interviews, I recommend either C++, Java, or Python. Personally, I see a lot of competitive programmer are uses C++ for its speed and STL, but Python is good for beginner. So choose the language which you are comfortable in. There is no rush. There is no different like if you use any other language, because the only thing here matter is the problem solving skill, not the language skill, right? And step two, and this is not negotiable, learn time and space complexity. This is really important, right? This is how we measure how efficient our code is. And if you cannot analyze your own code, you cannot optimize it. And in interview, optimization is everything, right? So the step two you should need to do is to understand time and space complexity, right? Then move to array and strings, the most commonly tested topics like traversal, manipulation, 2D arrays, mostly will cover over here, right? So once you're done with time complexity and space, then move to array and strings, solve some problem, got comfortable of solving such problem, right? And the next thing is learn basic maths, right? You should know how to calculate GCD, what are primes, what are LCM, what are arithmetics operations, right? That will really help you a lot. Then practice loops, right, and recursion deeply. Understand the call stack, and master STL or standard library, like whatever the language you are actually working with, right? So that will actually help you a lot. And STL collection, if you are working with C++, or not just about C++, even if you are working with Java or Python, there are a huge support of the libraries that will help you a lot in the coding interviews and even in the contests, right? So this is the first phase, where we are actually done with the foundation and language, and the time which you have to spend is 2 to 4 weeks. So this is the first one. Now if you are comfortable all of them, if you know how to write, like which language you are using, what's the time complexity, the basic understanding of all this concept, then you are good to go with the second phase. Now let's move to the second phase. So the second phase is, now we have level up. Phase two is where we learn the actual data structure. That's from the back, like that form the backbone of every interview question, right? So start with the linked list, like singly, doubly, learn how to reverse them, detect cycle, and find the middle elements, because they are the standard problem that will give you a good idea about how to work with those, right? And after that, then move to stack and queues, understand their application. Like monotonic stacks are a huge pattern in interviews. Then tree are next. This is massive topic, like binary tree, BST, drivers are like in order, pre-order, and height, LCA, all must knowns. So right, so once you are done with stack queue, then move to trees. Once you're comfortable with it, let's move to hashing. Hashmap and hashet are used in nearly every medium and hard problem. So understand their collision handling, that will actually really important, because in most of the interview, even interviewer asks you to actually build or actually design your custom hashmap as well. So knowing their internal behavior is really going to help you a lot. Once you're done with it, then move to heap and priority queue. Like these used in a problem involving top key elements, scheduling Dijkstra algorithm later, right? And finally, we have a matrix problem like spiral, rotation, 2D prefix sums. So these are really important questions which help you a lot, even not in just an interview, in your contest as well. So this is the second phase we have, where we have actually discussed about the data structures that will uh, help you to uh, build more confidence in solving such more easy to medium problems, right? Now if you are comfortable with all these topics, have solved a good amount of problem, and you should need to spend 3 to 4 weeks, right? Once you're done with, let's move to the second phase, or the third phase, sorry. So the third phase is phase 3 is where things start to get really exciting, right? This is where you learn the algorithm that solve problem, not just store data. So first start with the binary search. Sounds simple, but it's one of the most powerful tool, right? Learn to apply it not just on sorted array, but on the answer itself, right? This is game changer. So learn binary search. Let's move to sorting algorithms. Yes, learn merge sort, quick sort, heap sort from scratch. Understand their complexities. Also learn linear time complexity sorting, like counting sort and radix sort, right? That will help you a lot to actually know how things actually work behind the scene. And once you are done with it, then move to two pointer. These pattern alone can solve dozens of interview problems. So fast and slow pointer for linked list problems, sliding window for subarrays. So they solve most of the problem, right? So learn two pointer approach after that. And once you're done with, let's move to recursion and backtracking. So now next thing is recursion and backtracking. So this is the gateway to DP. As you know, like once you talked about recursion, then you are actually moving towards that dynamic programming, because in DP we are actually like reducing the complexity of the problem by making it iterative, not recursive. So first you should need to understand what the problem that why we are using DB, right? So practice generating subsets, permutation, solve NQ problems. Sudoku solver, get comfortable with recursion free, right? Understand the call stack behavior and how things actually work. Once you are done with recursion and backtracking, then we have divide and conquer, understanding the pattern through merge sort, quick sort, selection, and a classical case largest element. That will help you a lot, like how things actually work, where divide and conquer is actually going, right? And after that, there is last part, which is bit manipulation. Like you should know how and or XOR tricks, power of two checks, generating subset with bits. And we will love this, because not every time you use recursion to generating the subset, right? Sometimes using bit manipulations help you a lot. So try to learn that, right? So this is our third phase, where we actually discuss about the core algorithms. And if you just have to invest 3 to 4 weeks in this particular section, that will actually give you a good idea about how things are actually going on. Now let's move to little advanced phase, which is advanced data structures, right? By now we have a solid foundation. Phase 4 introduces the advanced structure that separate good coders from great coders, right? So graphs, this is huge topic. Understanding BFS and DFS thoroughly. Learn adjacency list versus matrix representation. What are the fallbacks? What are the use cases? Graphs appear in rear, road network, social network, dependency everywhere, right? So this is the really important. Let's move to like the another thing, which is sorted path. Dijkstra for non-negative weights, Bellman Ford when you have negative edges, flight virtual for all pair, sorted paths. So these are important. And another is try. You heard about try a lot of time. It solve a lot of good problem, like tree for strings, prefix searches, autocomplete, XOR in the your try for bit problems, very popular in product based interviews, right? Once you're done with, then you move to union find, which is also called disjoint set union, used for connected components, cyclic detection in graph, and path compression and union by rank, make it nearly one operations, right? So learn about how to use it. After that, we have another topic of segment trees. So range queries and point updated in overflow and lazy propagations for range updates. So these are really advanced topics, right? And then we have a fan victory, like, so these are really this section is going to be advanced data structure and algorithm, right? So once your foundation is good, then it make more sense for you to actually learn and solve the problem in this particular section with the topic similar to them, right? Now you done with, don't focus too much in the initially on everything. Let's try to learn graph, shortest path, and union find. After that, while solving problem, you will actually got to know about this particular concept, right? So don't rush while learning all of them in once. Now let's move to our phase 5, which is dynamic programming, which most of the people scared of. So how much time you have to spend? You have to spend 4 to 6 weeks. So let's move to the fifth section, right? The topic that's strike fear into the heart of most coders. But I promise you, once it click, it become one of the most satisfying topic in all the programming. The key insight of DP: break a big problem into like overlapping subproblems, solve each subproblem once, and store the result. That's it, right? So start with DP fundamentals, right? Understand memoization, top down, and tabulation. Bottom up, define a state, your transition, and your base case, right? Then move to 1DP, like Fibonacci series, climbing stairs, house robbers, jump game, simple but crucial for building intuition. Then move to 2DP, grid paths, longest common subsequences, average distance, 0 1 knapsack. These are classical interview problems, right? And now once you're done with them, let's move to DP on strings, like problem like palindrome partitioning, wild card matching, regex matching. These are the part of this. Now let's move to DP on trees. Tree diameters, maximum path sum, dependency scheduling. Like, so these are comes under it. And advanced interview DP like matrix chain multiplication, bit masking for traveling salesmen. You also heard about them as well, right? So these are like comes under this particular section. So these are also the like initially you should start with these topics till DP on trees, then move to bit manipulation, because initially you should first know how to work with DP, then move to some topic which might get confused you in the initial state, right? So this is the our like fifth section. Now move to a sixth section, which is graph algorithm, which is advanced. So don't judge directly or like directly jump into just completing the roadmap. Like go in the flow and learn everything step by step. Now we are phase like we are into the phase 6. Phase 6 depends your graph knowledge with along algorithm that are tested in senior level and FANG interviews, right? So like topological sort, use wherever you have dependency. Khan's algorithm with BFS or DSA based topological order, classical problem, code scheduling on lead code, right? So these are really important. Strongly connected component, these are another topics. Strongly connected component with Kosajaru and Tarzan's algorithm for directed graph analysis. And then we have bridge and article points, critical connections in network, finding bottlenecks, right? And then we have minimum spanning trees, crucials with DSU, prism with periodic used in network design problems. Then we have a network flow, right? Ford function, max flow, minimum cut, by part matching, which has tones of real world applications, right? So this is the whole section, and the whole things comes under the phase 6. Now let's move to the last section, which is interview preparation and practice. And now the final phase, phase 7, is where you take everything you have learned and turn into interview wins, right? So pattern recognition, this is the meta skills. Start recognizing which pattern fits which problem. Sliding window, two pointer, DP, graph, BFS. The faster you pattern match, the faster you solve, right? And then you have system design. Even for coding roles, you may be asked to design a LRU cache, a rate limiter, or a hash map. Learn these, that will help you a lot. Lead code grinding, yes, you need to grind, but grind smart. Start with the blind 75, then lead code 150, then lead code top interview 150. Quality over quantity, that will enough for you. Then mock interviews, this is crucial, right? And this is critical, and most people skip it. Use pramp or interviewing.io, practice under time pressure, learn to communicate your approach out loud, right? Then you have problem solving frameworks. First, clarify the problem. Second, think of the brute force solution. Third, optimize it. Fourth, code it cleanly. Fifth, test with edge cases. Always talk through your thinking, right? So this is really important. And the last thing, contest problem. Lead code weekly, code forces, add coder, code chef. There are so many platforms. Contests train for a speed and pressure. Even if you don't rank well, you learn fast, right? So algorithm, everyone, like, all right, so this is it. So that is complete DSA roadmap of 2026, 7 phases from absolute beginner to interview ready. I want to leave you with one thing. This roadmap looks long. It is long, but every single person who has cracked interview at top companies went through these exact topics. But the difference between people who make it and people who don't, right? Consistency, right? So the only thing which differ from the people, those are able to crack and those are not able to crack, showing up every single day, even when it's hard, even when you are stuck. You don't need to be genius, you just need to be consistent, right? So I will make detailed video on every single phase of this roadmap on the channel. So make sure you subscribe and hit the bell so you don't miss any of them. And if you find this video helpful, drop a like, and it seriously help the channel grow and help more people find this content. Comment down below which phases are you currently on. I read every single comment. Thank you so much for watching. See you in the next video. Let's get it.